Okay, then let's do a couple more reflections on these coordinate planes. Bum 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 bum. Do 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 do. All right, so reflecting over the line y equals x. So if you don't remember graphing, basically the line y equals x is a line that goes diagonally on the coordinate plane through the origin. So that's the line y equals x. And so if I gave you a rectangle, we call it A, B, C, D. This is the one that people usually like a formula for, and it's kind of easy to remember. Just if y equals x, then x equals y, and so that's why you're able to flip them. So this is 1, 2, 3, 4, 1, 2, right? So A was 4, 2, B is 6, 2, C would be 4, 1, 2, negative 3, and D is 6, negative 3. So all you're going to do, flip those points. That becomes A prime. Flip those points to 6, B prime. Flip those points, negative 3, 4, C prime, and then flip that point, you get negative 3, 6, and you get D prime. And that's it. So 2, 1, 2, 3, 4, 2, 1, 2, 3, 4, 5, 6, A prime, B prime, and then you get negative 3, 1, 2, 3, 1, 2, 3, 4, C prime, D prime. So this is the one that looks the weirdest when you've reflected it. And that's because you're reflecting it diagonally. Basically what's happening is if I were to take this piece of paper and fold it along this line, those two things would match. And this is one of the reasons too that I'm hoping to get you all tracing paper. This won't be perfect just because, well, one, I'm kind of bad at folding, which is kind of a weird thing to be bad at. And I've already made this not super even, right? But let's say I were to fold it. Now you can see my bad folding skills. Da, da, da. And I think I actually folded that not the way I wanted it to, but right. So I've got this here. Fold it, cross this line, and it matches there. Right? So basically you're folding diagonally, and that's what's going on. Yeah, and if I did the line y equals negative x, I would have just put negatives over it, and it actually would have just folded diagonally that way instead. Just one note. If your shape overlaps the line you're reflecting it over, your new shape can overlap its original shape. So let's say I had a shape something like this, right? So then when I flip it, my shapes are going to overlap each other, and that's fine. Perfectly okay. So the last thing you guys are going to have to do in this section is reflect over lines. Without a graph. And that's where the tracing paper comes in. So what'll happen is I'll give you a shape, and I'm going to ask you to do something like reflect it over this line. And then this is what you're going to have to do. Right? And it's not too bad. Trace it. Trace the line. Some people just put the endpoints, and that's fine. I like to draw the line, right? Flip it so that this line matches exactly where you were. And now we can just do a little scribbly here. Boom. And now we've reflected it. And then usually I just trace it over again. So one thing to note when you're reflecting is that the distance from the reflection is the same. Meaning that this is 1 centimeter, then this is 1 centimeter, right? If this was 5 centimeters, then this side would be 5 centimeters. So, it just preserves the distance. And that's important because a true reflection will always do that. Now, that last thing that I can do is have you reflect over multiple lines. And really, it's just having you do double reflections, but there's a reason for it, which you are about to see. So basically there's two types. So the first one has to do with parallel lines. And 8 minutes I've talked already, so let's try to get this done, right? And then usually what I'll do is I'll say reflect over the line A and then B. So these two lines are parallel, and that's going to do something, I was about to say cool. I don't know if you guys think it's cool. I think it's cool. So really all you're doing is what we did before, right? And then, so I don't get confused, I like to just put A and B. So you're going to reflect it over this line, right? Trace. And then, if you have room, you can just directly trace it over that line B. So just one line, then the next. And obviously you could tell I wasn't super careful about it. That's fine. And what happens is, when you reflect it one time, it went backwards, but you reflect it again, it goes forwards again. So when you reflect over parallel lines, it actually turns into a translation. It's just moved. So really, reflecting twice is just moving it from here to here. It should look the same as the original, like in the same direction, everything. And this isn't something that I'm going to make you do, but just so you know, if that's the distance between these two lines, it's just moved double the distance between lines. So this has a little ruler on it. It was about 1 and almost 3/10. Actually, I don't think these are measured in tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16. So 3/16. So then if you measured from here to each one, it's about 2 and 6/16. So literally it's this distance, double it, and that's how far it's moved. You don't really need to use that though. The last thing I can do is have you reflect over non-parallel lines. Man, I don't really know what's going on today, but I feel like I'm exceptionally more boring than usual. So I really don't know why that is, but oh well. I guess you guys are just dealing with it right now. Alright, so then I give you a shape. And once again, I don't like that shape because this bottom is supposed to be a straight line. You're just reflecting it twice. These are the ones I think it's really important for you to trace your lines, just so you don't get confused. So AA, and then line B. It ends up right there. So this one's a little different in that it's not oriented the same. And really what's happening when you reflect over non-parallel lines, it turns it into a spin, which you know is called a rotation. So when it's non-parallel lines, what ends up happening is you take that shape and it spins around. Not that you can see that because probably my hand is in the way. So, right, non-parallel lines turns it into a rotation. So right there. And that's basically it. It's a rotation, which is double the angle between the lines. But once again, that's not something we're going to do this year. So whatever angle this was, if you doubled it, that's kind of how far it gets turned. And yeah, that's that, yo. I will, in my defense, by the way, it is like 4:30 in the morning, so maybe that's why I'm being kind of boring today. Who knows? Or maybe that's just me always.